supposed to yesterday, right? So you can start putting your collab, collab notebook links in the chat here once you're done. And if you're having any other doubts, you can ask. If you're using Jupyter Notebook, then you can download the IPYNB. You can download the notebook, and you don't even have to download it. It'll already be there in your file system. You can just upload that to Google Colab and share the link. Guys, the splitting of your data set, the pre-processing, all of that needs to be done only once. Okay. And you just have to train different algorithms, but the pre-processing and splitting the data set to train and test samples, scaling, all of that happens only once. So if you have done it more than once, please change. I saw some of you who have done it separately. Hema, what you can do is you can just, anyone with the link should be able to access it, right? So you just enable that and I'll be able to see. Yeah.
Ma'am, I'm not able to execute the one with the graph, ma'am. It says your section crashed after using all the available RAM.
You cannot plot a graph itself for that data set. You can only plot a graph if you had just two parameters. What will be your parameters in the x-axis and y-axis if you have to plot a graph with this? You have 5 to 6 features, right? It's not even possible to draw, have a graph itself.
Okay, ma'am.
Okay, so I think many of you have sent the files, and there are many of you who still have to. So you can, the ones who have not sent it yet can continue sending. And parallelly, what we will do is we will complete our discussion that we had to have with respect to deep learning, right? So we'll start and finish that. And whoever has to still finish and send it can send it by the end of the class. And I have noticed that many of you have just copy pasted the content from your friend or I don't know whom. And I've seen a lot of duplicates of the same notebook with, all the code cells are in the exact same way. So because this is just a task, I will accept it for this. But next we'll be working with 2 projects. And in projects, if you guys are just copy pasting the thing from another person, the same thing, both, I see multiple people are submitting, then that would be taken very much seriously. Okay. So you need to do it on your own. It's not a group assignment, and we will not accept group submissions. Okay. Anyway, so now we'll continue with understanding the basics of deep learning. Okay, so I'll share my I'll share my screen. Yeah, so now let's start off with understanding what deep learning is, right? So till now, we saw a lot of machine learning algorithms. Now, all of these algorithms were essentially built on the idea, it was basically built with a mathematical structure in mind, okay? And from, now onwards, we are basically moving to a different ideology behind building our algorithms, right? So now when we look at this picture, do any of you know what is present in this picture? What exactly are you seeing? Any idea? Anybody? Okay, so microscopic view of a cell, neuron. So yeah, this is a microscopic view itself. It is a microscopic view of neurons. Okay, so this is exactly how neurons look in our brain, right? So this is how it actually looks. Now, if you look, that was actually a collection of multiple neurons, right? And in our brain, we have thousands and millions of such neurons that all of them work together and help us take decisions that we take, okay? And all of them are trained to, perform a particular function. So if we, find out the most atomic part of it, which is a single neuron, this is how a neuron looks, okay? So we have multiple parts to this neuron, okay? So we have, you can think of it as a head and a tail, okay? So let's not go into the details in, biology terms, but basically we have a head and a tail. The head receives input that is basically through dendrites. It receives input from other neurons, right? Some electrical, some neurological signals is received, okay? Some neural signals from the different neurons that it is connected to. And here some type of processing is done. And the result of that processing is given out to many other neurons, right? So this is the structure of how the neurons work, and millions of these together actually help us take the decisions, okay? So this is how generally a neuron works or looks, okay? So the same thing we try to replicate with a mathematical way of doing it. And that is how we have come up with this. So we basically have n different inputs. Okay. It's not just limited to two. We've just simplified it. Like, let's say we had two different inputs. And then there is a processing unit in between, which is basically going to do some processing based on the values from input one and input two. And it gives an output. Now, even in case of the brain, when we see, it's not that any single neuron is responsible for the decisions that are taken, right? So it's not like just a single neuron is deciding or taking a particular decision, and it's not even that 5 or 10 of them are. There are a chain of different neurons, and different chain of neurons for different types of decisions, and this chain can be like really long, and it is a huge group of neurons that take a decision individually. A single neuron is not very strong in basically taking this decision. In fact, it is not capable of doing that itself, okay? So it is a combination of all of these together that cause it. So we have a processing unit and then an output to it, okay? So this processing unit does a very simple mathematical operation between the input to get the output, okay? So this is what you can think of, a single neural entity that we have designed in a mathematical module. These things are called as perceptrons, okay? So that is the name that is given in an artificial neural network. Each of the neurons basically correspond to perceptrons, which try to mimic the behavior of a neuron, okay? And a neural network, a very simple neural network, basically has three different layers, and it can have, it has three types of layers, but it can have n number of layers, okay? So we have an input layer, we have hidden layer, and output layer. So these are the three different types of layers we have, okay? Now, in case of input, we basically, whatever you've collected information, whatever is it that you're having in your data set, those values are provided as input in the beginning, okay? And these values are transferred through a single hidden layer or multiple such hidden layers. The simplest layer that we have done is with a single hidden layer, okay? Almost all neural networks have more than 3 layers. They have n number of hidden layers, with each layer having multiple different number of perceptrons. There is no restrictions on that, okay? So we have n different perceptrons, and we have these neurons, which we have the input layer, which basically gives the input to all of the hidden layers, okay? And these hidden layers in the end actually like perform some math. It is, if you notice that this perceptron is receiving the input from all the three, okay? And is giving its output to the output neuron. So the output neuron generally represents, the number of neurons in our output layer generally represents how many classes we are having, if it is a multi-class classification. If it is just if it's just a yes or a no answer, it could have, 2 perceptrons, or it could just have 1 perceptron, and the absence of, true indicates, the absence of true indicates false, right? So we could use a single perceptron for multiple values, or you can have 2 individual perceptrons as well. Generally, we have, let's say, 5 classes that we're classifying our data to. Then we'll have 5 different perceptrons in our output layer, with each perceptron indicating the value of that particular chain of layers, okay? So this is how, in a nutshell, a neural network works, okay? Do you guys have any doubts regarding what we have discussed so far? You can ask in the chat section if there's any doubts. So basically with perceptrons, what we're trying to do is we're trying to mimic the behavior of, we're trying to mimic the behavior of, let's say, a neuron, right? So in a neuron, what do we usually do? We collect information from different neurons, do some modification and share the new value with other neurons, right? So that's exactly what we do in a single perceptron, okay? And we group some of these perceptrons into a single layer and have multiple layers stacked on each other. This will create an artificial neural network, okay? So like here we had discussed about how we have, a single hidden layer and a single output layer and an input layer. We knew that, you can have more than one hidden layers, right? So here we see a more general output wherein we have a single input and a single output layer, but we have multiple hidden layers in between them, okay? So there's a lot, and all of these connections are made based on the layers, right? So each layer gives gives its output to as an input to the next layer, right? So that is how all of this works, okay? Now, what is the content of a single neuron, right? I mean, what is this content of a single perceptron? So if we had seen that there was something called as a processing unit, but what exactly is this processing unit and what are we going to do under it is what we'll understand here, okay? So there are two aspects to the processing unit. So the first part is called as the weighted sum, okay? And the second part is called as the activation function. So the first part, which is the weighted sum, is basically a product of weight and whatever value that's being passed, and you find the sum of all of that. So let's say the previous layer, we have n different inputs that we're getting. Each input x1, this is actually x1. So x1, x2, x3, there are multiple inputs that we're getting. And we have different weights, W0, W1, W2, and so on. Okay. So basically, what is the thing that we're going to add is that I'm going to multiply the weight with the value, weight with the value, weight with the value, weight with the value. So each of that will result in a value, right? So it's going to be a product of the weight and the value. So WNXN, right? So you can generalize it as that, okay? So it's going to be a summation of WIXI, wherein I ranges from 1 to N, okay? So that is basically what it is, okay? So this is going to be the weighted sum part, followed by an activation function. So there will be an activation function on top of this particular value. Okay. So this value, it's basically going to be a graph that we're going to use. There are multiple activation functions. We'll learn about all of those activation functions in detail. For now, all we need to know is that the processing is split into two parts. One is the weighted sum and the next is an activation function. So for me to perform some type of basically I have multiple inputs, but I'm going to have a single output. So because of that, there should be some way in which I'll combine all of these inputs, right? That is why we take the weighted sum. Now, once we combine, we have basically a cumulative magnitude of the input that we have got. Now, this final input that is there, we'll perform one mathematical operation on that, which is through the activation function, and that is sent to the output. Okay, so that is how it works. We have different activation functions. Now, one of the activation functions is called as the threshold function. Okay, so in the threshold function, what happens is, if the value that is our weighted sum, what we get in the end, if that is greater than 0, then my output is going to be 1. And if that is less than 0, then my output is going to be 0. Okay, so what happens is, now further the graph, I mean the neuron, is only going to give you an output of either 0 or 1. There's no other values that can exist. Okay, it's only going to be it's going to give a true or a false value. If the weighted sum that is results in a value that is positive and greater than 0, that means I'm going to give 1 as my output. Otherwise, it's going to be 0. Okay, so that is how the activation functions are going to work. That is how the threshold activation function is going to work. Okay, Next, we have the sigmoid activation function that we had already seen earlier, right? So this sigmoid activation function, we had already discussed the equation. This function will basically result in a value that ranges between 0 to 1. And it's going to take all the intermediate values as well, right? So it's not just 0 or 1. It's going to range from 0 to 1, right? So this is how we'll get an output in case of sigmoid function. So basically, whatever the weighted sum is, that will be the value here for x. And our final output that we get is going to be a value between 0 to 1, okay? Next, we have something called as the rectifier function, okay? So in this function, what happens is, you basically, if there's any negative value of the weighted sum, for all negative values of the weighted sum, I'm just going to give my output to be equal to 0, okay? So if my value is -5, -5,000, -5 million, whatever it is, I'm going to give my output to be 0. And if it is greater than 0, all of those values, I am going to give it as, I'm going to, not do any modification. It's going to be the same as the value. So it's given by the function of phi is equal to max of x or 0. So whatever the value is, either that value or 0, whatever is the higher value, that is what we'll return. So this is another activation function. Next, finally, we have another activation function, which is called as the tan hyperbolic function. This is basically the tan h, graph. This is how the tan h graph looks, right? So the hyperbolic curve. So the values are going to range between -1 to +1. Okay, so depending on what type of output we actually need, okay, we can decide what will be the activation function that we will use. Okay, so do you guys have any doubts regarding the activation functions that we've discussed so far? Okay, so no doubts. We'll continue. So next, when we have understood that we have different activation functions options, so what you need to understand is that in hidden layer and the output layers, right? So in all of these different layers, you don't have to use the same activation function, okay? You can use different activation functions in different layers, and in fact, for different perceptrons as well, okay? Generally, people fix certain activation layers for certain layers, and you can really play around with all of these, okay? Now, let's take a simple example wherein we're trying to find out the output that is basically, what is the selling price of a house, okay? So this value, so we have taken a very, very small, very, very small artificial neural network just to understand how all of the different parts work, okay? So we have basically different values that we're having, which is area, number of bedrooms, the distance to the city, and what is the age of the house. So these are the 4 parameters that we have picked, okay? Now, each of these things are part of our data set. So we have values that is x1, x2, x3, and x4 associated with them, okay? So now finally, our perceptron is going to take the weighted sum of all of this. So what would be the weighted sum? That's W1 into x1 plus W2 into x2 plus W3 into x3 plus W4 into x4, right? So this is going to be our weighted sum followed by an activation function. Since this is a really small neural network, let's imagine that there is no activation function here, okay? So basically, these weights can be assigned any value from -infinity to +infinity, okay? There is no restrictions on the values that is allocated to the weight. Now, the entire process of our training is to find out and assign the most optimum weights for all of these different values, right? So W1, W2, W3, and W4. We want to make sure that we're giving the best weight values to each of them. Now, if we only had a data set that was this, and if our neural network was this small, we would have had only 4 weights, correct? Now, in this other scenario, I've just added one hidden layer, with only 5 perceptrons in between, right? So that is all the modification is. But just adding this one layer, now what are the number of weights that are there now? So for this perceptron, I'm getting input from 4 places, right? So for each perceptron, I'm getting an output from 4 different places. So that becomes 5 fours are 20, right? So we have 20 weights in this slot, okay? And then each of these outputs are given to our output layer. So here what happens, we have another 5 weights. So we have a total of 25 weights when our data set is, when our neural network is as small as this. We're already having 25 values, and we want to find out the optimum value for all of these 25 all of these 25 variables. We have to find the most optimum weight simultaneously, right? So this is the challenge that is, there when we are working with the data set. When we're working with the neural network, right? So we need to constantly, as the learning is happening, the learning always happens in smaller batches. So you train it based on, you see what is the output you're getting, you compare it with the actual output. So this gives us basically a cost function, okay? So which is basically your output value, you subtract it from the actual value, and this error you've got the square so that you don't have negative values, right? And then that one you find out the cost. So this is the formula for the cost function. It's a very popular cost function. So if the cost is very high, that means a huge modification needs to be done on weight 1, such that it balances out. If the value of cost C is very low, that means a small modification in the weights can be done to make sure that the value is more closer to the actual value. So during training, basically, initially the weights are assigned random values, okay? And slowly by training with all of the different samples, you adjust the cost, you find out what is the cost, and you adjust the weights, and you try to keep getting better at it, okay? So that is how it works. So for every single data set, now let's say this was a data set. So what would I do? I would basically take my neural network. I would pass the first row, and I will get a certain output, and the actual output is something else. So like I find out the difference for all of them, and together finally I find out what is the total cost, right? So in this data set there were 8 rows. So I do 8 of these plots to understand the difference, and then find out the cost, and then I adjust the weights back to all of them, right? So now if I just plot a graph of this cost, then we see that basically our output with the cost, okay? So if I plot a graph between this, our output is going to be a parabolic curve, okay? And it's not necessary, it's because it's a square function that we're using, it's going to be a parabolic curve. We need to basically find out the lowest value of the cost, right? So if our cost function is really small, that means the difference between y hat and y is very, very less, correct? And that is what we want to achieve. So that would be our best scenario. And we want to find out exactly this value, correct? But we cannot, we don't have this graph with us. We'll only get this plot when we, find out the cost so many different times, correct? Which can be computationally very expensive, right? So that is why we have another process which is called as the gradient descent, wherein what we do is, in the beginning, we perform large, modifications in the weight, okay, and see how the cost varies with it, right? So here, basically, now in this graph, let's say we start from a point here, and I find out the cost, and basically you draw a tangent, the slope of this curve you understand, and the slope is downwards. So, and it's quite steep, correct? So I do a large change in W. And by doing this large change, now my error has gone to some place here. Let's imagine, right? So basically, I've gone through all of these steps and reached here because I did a large modification. We don't want to do every single step. I don't want to just take small changes and slowly come here. There will be a lot of iterations that I need to go through. So I just do a large iteration because I see the steep of my tangent is high, right? And then now again, let's say I reach this point with my new value of weights. Here, I will again find out what is the error, right? I'll find out the cost function, and we'll find the tangent to this. Here, the slope of the tangent is less steeper, and it is in the opposite direction, right? So if I had increased my weight, I know that I should decrease it. If I had decreased, then I know I should increase it. So whatever operation I've done, I have to do the opposite of that to a smaller magnitude, right? And then we, let's say we move to some point here. Again, here we find out the tangent, the slope is, less steeper, right? So a small modification of the weight is sufficient. So basically by doing this, we try to reach the most optimum value of the cost function and the most optimum value of all the weights with minimum iterations possible, right? So this is what happens in case of a gradient descent and stochastic gradient descent algorithms, okay? Now, next here, we are looking at how exactly is this neural network built, right? So if the first perceptron here is basically taking input from all of the 4 different input perceptrons, and it's not necessary that there will be a positive weight or a negative weight assigned to all of them, right? So sometimes the most optimum value, you may find it later to be 0, or sometimes you might yourself just drop it, right? So you might just say pick only for these 2, right? So each of, it's not compulsory. If I connect every single input perceptron to every other hidden layer perceptron, that would be a fully connected layer. It is not necessary that every time I have to have fully connected layers itself, right? I can even randomly pick some perceptrons to get input from a subset of the input perceptrons. Similarly, every layer this can be done, okay? So there is no hard and fast rule regarding which one we need to do. And also when you, even if you pick all of them, when you optimize, when you find out the most optimized value of weights, it is possible that some weights are assigned to the value 0, so you're not really taking from there, okay? So this is it with our discussion with respect to artificial neural networks. It's just a brief overview of how it works, an overall picture we are trying to get. If you're having any doubts regarding this, you can ask in the chat section. Otherwise, we'll proceed with convolution neural networks. Okay, so whoever is left with sending the links with your notebooks that you have to submit, you can put that in the chat. Okay. We'll start off with convolution neural networks in the next class, because if we start today, we'll not be able to complete it. We have a lot to discuss under convolution neural networks. So we'll discuss that tomorrow, and that will be the end of neural networks. It's okay. And after that, we can move ahead and continue with the project. Okay, so if you guys are having any doubts regarding what we've discussed, you can ask in the chat right now. And the ones who have to still submit your submit regarding the submit the task that is allotted, you can put in the chat. I believe that there are many people who are still left to do that.